Hi, this is Rakesh Gupta, and this is my take on question 5 of end-term video assessment.
So I would like to start by talking about what Laplace transform are. So if we have a function f of t, and for this function to have a Laplace transform, it has to satisfy two conditions which are as follows. These conditions are, one is for t should be t should be greater than equal to 0, and the second condition is for any constants m and k, it should satisfy this. Sorry, this is less than equal to. Now this condition is also called as growth restriction. This also means that the function doesn't grow very quickly, and the Laplace transform of a function f of t is given by this equation. So here there is f of t, and the Laplace transform of it is given by integral limit 0 to infinity e power minus st multiplied with f of t dt. So now when we come to the question, we see that our f of t is given as f dash. So I'm just going to take it as f dash of t for now. So continuing, instead of f of t, we are going to write f dash of t as it is given in the question. Now we will use integration by parts, the formula for which is given by this. Now when we use integration by parts, we will assign u as e power minus st and v as f of t, sorry, f dash of t. Now when we solve further, we'll get u is e power minus st and integral of f dash t is f of t. Then the differentiation of e power minus st will be minus s multiplied with e power minus st, and then multiplied with the integral of f dash of t, which is f of t. The limits for these is 0 to infinity. Yeah. Now when we solve further, I'm just removing this negative sign and putting it in the denominator. Now we take s outside, multiplied with the integral e power minus st f of t dt. Now we can see that this integral Sorry, I forgot to write the limits. 0 to infinity. Now we know that this integral can is actually this formula right here. So we can write this as Laplace transform of f of t. I'm just going to write this term first. So now this term can be written as upper limit minus lower limit, right? So for the upper limit where t is tending to infinity, minus the lower limit where t is tending to 0. So if you see, if you remember, initially we had the condition that we had the growth restriction that f of t is less than equal to m into e power kt, where m and k are some constants. And over here, when we look in the denominator, we just have e power st. So according to this, what happens is the denominator e power minus st is going to grow at a much faster rate than the numerator f of t. So when that happens, when t tends to infinity, the denominator tends to infinity even more quickly than the numerator. Hence, this term becomes 0. So this term becomes 0 minus, we just substitute t as 0 over here, which will give us f of 0 by e power minus st, which e power 0, which is 1. So that's all. We can write the Laplace transform of f dash of t can be written as, wait, there is s multiplied over here, s times of Laplace transform of f of t minus f of 0. Now if we assume that the function f is not in terms of t and some other things, I'm just going to write it as in a general way, which is now this is what we were asked to prove in the question. That's all. Thank you.